Hello everyone, greetings from VJEC JYOTHI Institute of Engineering and Technology. This is by Manohar Reddy, Department of Cybersecurity, Data Science and AIDS. Today I am going to talk on the topic of memory allocation technique in the operating system. So memory allocation techniques. So first of all, what is meant by memory allocation? So memory allocation is the process by which the operating system assigns memory space to the programs or processes so they can run properly. So in the memory management, the memory allocation is one of the technique that assigns each and every resources to the processes. So here the operating system assigns memory space to the processes or programs. If you are not allocating the memory, then what is the need of program to be executed? So to execute that program, to execute that process, to be completing, the memory should be needed. So memory resource is needed. So that resource is allocated to the process. So here the memory allocation is the process by which the operating system assigns memory space to the programs or processes. And memory allocation techniques are used by the operating system to allocate free memory blocks to the processes. So whenever the blocks are free, then only the memory manager will call the process manager to allocate the particular memory blocks. So then process manager comes to the memory blocks and assigns each and every process to the blocks. What are the blocks are free? So here the OS assigns each and every block to each and every process. So the process contains the process size like 1 KB, 2 KB approximately like that. And similarly the memory size is also units in the terms of KBs. So memory size blocks are in the terms of KBs. So when the process entered into the memory to utilize the resources, it always checks that the process size is greater than or equals to block size. So if the block size is greater than that process size, then only it allocates the particular block. If the process size is greater than that block size, then the process cannot be allocated to that particular block. So here you can see the sum of the blocks are available with the sizes and the processes are available to locate the resources. So here the particular P4 is 200 KB, P3 is 100 KB, P2 is 303 KB, 313 KB, P1 212 KB, like that. So all these processes are having their sizes, and according to the block sizes they are allocated in the blocks. So based on this allocation, the memory allocation is having two types of allocations. One is fixed sized allocation. Also called as fixed partitioning. So fixed size allocation is called as fixed partitioning. And the second one is variable sized allocation, dynamic partitioning. The variable size allocation, dynamic partitioning. So fixed size allocation, the name itself, the memory blocks are having the fixed manner. So here you can see the fixed size allocation is also called as fixed partitioning. In this fixed size allocation, the main memory is divided into fixed partitions or equal or predefined size. So we can say that what? The memory is divided into fixed partitions of equal or predefined size. So equal sized blocks or predefined sized blocks. We can call them as fixed partition blocks or predefined sized blocks. Of each and every partition can hold only one process. So each and every partition, the partitions are nothing but the blocks. The block, each and every fixed partition block is allowing to hold only one process. Suppose take an example here. The memory is having memory manager saying that what the memory total size is 1000 KB. So how that memory 1000 KB is allotted with the fixed partitions of equal sized blocks? How they are allocated? Fixed partitions of equal sized blocks. So the 1000 KB is divided into 4 processes, 4 partitions or 5 partitions, whatever it may be. Suppose take an example for the 4 partitions. Each and every partition of the block is having 250 KB. So here the process 1 is having 250 KB, process 2 is having 250 KB, process 3 is having 250 KB, process 4 having 250 KB. All together is having 3000 KB. If 5 partitions made, what will happen? All these sizes are 200 KB, 200 KB, 200 KB, 200 KB, and P5 also 200 KB. So like that, fixed partitions of equal sized blocks are predefined size. Predefined, why we are saying the predefined size? Means for each and every partition you should maintain the particular 100 size, 100 KB of the size, or 200 KB of the size, or 150 KB of the size, whatever it may be. You can mention if a process requires 100 KB, it still occupies 250 KB. So this is one of the problem when it is having fixed sized allocation. If any process comes with the lesser size of the process, if it is occupies the memory, if it is occupying the blocks, if the block size is more greater than that process size, what will be the situation? All that remaining size, remaining memory is wasted, because the process is having only 100 KB, but the memory block having 250 KB. So it utilizes only 100 KB of this entire 250 KB, and remaining 150 KB is wasted. So this is the somewhat disadvantage of this fixed sized allocation. So the main aim of fixed sized allocation is to maintain all the fixed partitions of equal sized blocks or predefined sized blocks which are already mentioned by the memory manager. So whenever the process comes to allocate the resources, allocate the block, then it always checks that size of the block and the size of the process. If the size of the block is greater than the size of the process, it allocated. If the size of the block is less than that process size, it could not be allocated. It could not be allocated for the process. So according to that, the advantage is what? Simple to implement. So if any block is free, it is automatically allocated, but based on the sizes, and simple to implement and easy memory management. Easy memory management. So we can easily allocate each and every process into the memory block, and if once its allocation is over, then automatically free up the memory from these blocks. And disadvantage is what? Internal fragmentation. That is what? Memory wasted inside of the partition. So as this example, 100 KB is requiring for the allocation, but the size of the block size is 250 KB. For 250 KB, so 100 KB is allocated and remaining 150 KB is wasted inside that partition. So that memory wasted inside that partition is called as internal fragmentation. Internal fragmentation. And the limited number of process, because the memory is having 1000 KB, we are having the partitions with the 100 KB, or if we have the partitions only 2, then 500 KB and 500 KB, only 2 partitions are there. So the limited number of process only utilize the particular allocation. So this is the fixed sized allocation. And the second one is variable sized allocation, or also called as dynamic partition. Variable sized allocation or dynamic partitioning. So in this variable sized allocation, memory is not divided into the fixed partitions. In previous slide, we have seen that the 1000 KB of the size is divided into the 4 fixed partitions with the 250 KB, 250 KB, 250 KB, 250 KB. But in this variable sized allocation, not like that. We are not divided into fixed size partitions. We are divided into the variable sized partitions, different sized partitions, dynamic partitions. So that we can say that the 1000 KB of the size is divided into number of processes, number of blocks. Suppose if we take any 5 blocks or 6 blocks, we can take any of the block size, 300 KB of the block size, 200 KB of the block size, 150 KB of the block size, 100 KB of the block size, 50 KB of the block size. Like that, you can divide any number of not fixed blocks, any number of variable sized blocks. So, but from the processes, how many processes that you want to allocate that resources, that is only the thing you have to do. So, if any process comes for requiring the memory 200 KB, if the memory blocks are having any 300 KB of the size, then easily accommodated, easily allocated. And similarly for the P2 also, 300 KB of the size block is available, then easily allocated. So here the 300 KB is allocated and 200 KB is also allocated and 150 KB also allocated. because they are all variable sized blocks. They are all variable sized blocks. If one block is not enough, then it chooses for another block with the same size or with the more sizes. So if any size is not available, then it is not accommodated as per the fixed size partition, variable sized partitions, whatever it may be. If the size of the process is greater than that memory block size, then it cannot be accommodated. But only the thing is, the variable sized allocation reduces maximum internal fragmentation, because if internal fragmentation, in the internal fragmentation, if the block size is more, if the process size is less, after utilizing the process into the memory, the remaining all the memory will be wasted. So that internal fragmentation occurs in lot of cases for the fixed sized partitioning. But in this variable sized partitioning, not like that. If any process comes, then memory manager decides that the which block is available for the process, then it is automatically allocates and it automatically completed. So memory is allocated exactly as required. So the from main advantage is the better memory utilization. So better memory utilization. Why I can say this better memory utilization is, suppose the memory 1000 KB is there. I am dividing that all the 1000 KB into different variables, different blocks like 350 KB of the block, 250 KB of the block, 150 KB of the block, 100 KB of the block, 50 KB of the block. Like that, if I divide all these blocks, so this is the block 1, block 2, block 3, block 4 and block 5. If all these blocks are there, if any process comes with the 300 KB, suppose P2 is having 300 KB. So out of these all, 300 KB is suitable for which block? It is supported for B1 block. So it is accommodated. So P1 is utilized. And second block, second process is what? P2. So P2 is what? 300, P1 is what? 200 KB. So 200 KB is looking for the block B2. And similarly P3 150 KB. Is there any block is available? Yes, 150 KB. So the better memory management is there. So this is the better memory utilization for this variable sized allocations. And the disadvantage is what? The external fragmentation occur. So external fragmentation. What is meant by external fragmentation? Suppose if any process comes with the size like 400 KB, if any process comes with a 400 size KB, if 400 size KB block is not available, if any block is not available with the 400 KB of the size, but altogether is having more than 400 KB size, all blocks together having more than 400 KB of size, but no block is having 400 KB of the size, then this process cannot be accommodated into any of the block, even though all blocks together having more than this 400 KB of the size, but not able to accommodate because each and every block is not having 400 KB of size. The thing is, the process has to allocate each and every block, not for the all blocks, right? So because of that, this all blocks together having more than 400 KB of the size, but the process comes with the 400 KB of the size will not be accommodated. This is called as external fragmentation. So the fixed size allocation leads to internal fragmentation, and the external variable sized allocation leads to external fragmentation. So in this also less fragmentation, internal fragmentation occurs, but compare with the fixed sized allocation, this will be leads to less internal fragmentation. But variable sized allocation allows maximum external fragmentation, because altogether having more than size, but more size of the process size having is an issue. So that cannot be accommodated into individual block, right? So this is the problem of external fragmentation in this variable sized allocation. So external fragmentation occur, and the memory management is more complex. Memory management is more complex. This is the thing that we have to understand from this variable sized allocation. And the comparisons of both allocations. So as we seen that the features, what are those? Memory division, memory usage, fragmentation, flexibility, how they are allocated. So the memory division is for the fixed size allocation is what? Fixed partitions. So each and every memory size, entire memory size is divided into fixed partitions. 100 KB, 100 KB, 100 KB or 200 KB, like that fixed partitions occurs. But in the variable sized allocations, dynamic partitions, 100 KB, 200 KB, 300 KB, 50 KB, 70 KB, 80 KB, like that, all together dynamic partitions occurs. The memory usage may waste memory in the fixed sized allocation because it always leads to internal fragmentation, right? So that leads to maximum waste of the memory. Here, the variable usage allocation, it not occurs maximum cases, it uses efficient way. And the fragmentation, in this fixed sized allocation, internal fragmentation occurs. So as we seen that after utilizing the process from the block size, the remaining block size get wasted. So that leads to internal fragmentation. External, in this variable sized allocation, external fragmentation. Altogether having the size compared with the process size, but process size cannot be accommodated into individual block size. So then it leads to external fragmentation. And flexibility. So fixed size allocation is less flexible. Why? Because why we are saying that means it always checks that each and every block size. So all processes entered into the blocks, all utilization, more than one blocks are wasted, more sizes are wasted. So that is not we can say that it is in flexible manner. So in this variable size it is more flexible compared with the fixed sized allocation. Thank you all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.